Hey everyone, and welcome. Today, we're going to talk about something you've probably used thousands of times without giving it a second thought: the humble screw. But trust me, behind that simple spiral is an incredible world of high stakes engineering, wild material science, and just mind boggling precision. Let's get into it. So, what's really the difference between a 10-cent screw you grab at the hardware store and a $100 one they use in surgery? I mean, is it just a fancier metal, or is there something more going on? Well, as you're about to see, the answer is this fascinating journey of creation, protection, and perfection that turns a basic piece of metal into a critical, sometimes life saving piece of tech. So, where does our screw's story even begin? It all starts with how its threads, the spirally bits, are born. And right from the get go, there are two main paths it can take. The choice between them completely changes the screw's strength and its purpose. It's basically the difference between being forged in fire and pressure or being delicately carved with absolute precision. Okay, so this slide really lays it all out. On one side, you've got thread cutting. You can think of this like sculpting. It literally carves away metal to create the thread. It's great for custom jobs, but it cuts right through the material's internal grain structure. But then you have thread rolling. This is more like kneading dough. It uses a ton of pressure to form and displace the metal, not remove it. This keeps that grain structure intact, which makes the screw way, way stronger, sometimes up to 30% more resistant to fatigue. And that right there is why the grain structure is such a big deal. Research, like the study mentioned here, shows that keeping the grain continuous, like you get from rolling, makes the thread so much more resistant to breaking under stress. By getting rid of those tiny, invisible weak points that cutting can create, rolled threads can handle way higher loads without failing. And if you're talking about a bolt in an engine or a critical structural fastener, that's everything. But getting the shape right, that's just step one. A screw has a really tough job. It has to fight against constant vibration, friction, and, in some cases, even the environment inside the human body. So, the next step is to give it a kind of protective armor, using some seriously cool surface treatments. We've all been there, right? You put together some furniture, and a few weeks later, you hear that telltale rattle. Yep, a loose screw. Now, for a bookshelf, that's just kind of annoying. But imagine that same screw in an airplane wing or in your car's braking system. That same loosening could be absolutely catastrophic. So, how do you stop that from happening? Well, one of the most clever solutions is a chemical agent called a thread locker. You can think of it like a super specialized glue for threads. It gets applied and it fills in all the microscopic gaps between the screw and the hole. This creates a powerful bond that dramatically increases the force needed to loosen the screw, basically locking it solid against vibration. Now, let's take this to a whole other level, inside the human body. For medical implants, the screw's surface needs actual superpowers. Some get carbon coatings to make them super slick, reducing friction so they go in smoother. Others have coatings like hydroxyapatite, which is amazing. It actually tricks your bone into growing right onto the screw, creating a biological lock. You can even use advanced texturing on the surface to give it a better mechanical grip right from the start. So, you might be thinking, okay, problem solved, right? A perfectly formed, perfectly coated screw ready for surgery. But in the world of high-performance engineering, there is always another challenge just around the corner. And here's the catch. Research shows that while a coating is great on the first try, if a surgeon needs to retighten that screw, it can actually increase friction under the screw head. This makes it harder to get the screw to the exact level of tightness, what engineers call preload, that's needed to hold the implant securely. It's a really, really delicate balancing act. Okay. So we've formed the screw, we've treated its surface, now for the final exam, making sure it is absolutely 100% perfect. Because in this world, there is zero room for error. And that's where the science of measurement comes in. This science is called metrology. And for a high-performance screw, we are talking about verifying its dimensions down to the micron. That's 1,000th of a millimeter. Every single angle of the thread, the distance between them, their depth, it all has to be exact. And why? Because even the tiniest flaw could compromise the entire structure that it's holding together. So how on earth do they check something that small with that much precision? It's a super high-tech three-step process. First, they use a high-resolution 3D scanner to create a perfect digital twin of the screw. Then, powerful software crunches all that data, analyzing every single nanometer of the thread. And finally, it compares that data against the original design to flag any deviation, no matter how ridiculously small. And that's the whole point of all of this. A tiny, invisible flaw in the shape of a thread could prevent it from locking in correctly, which could lead to instability or, worst case, failure. This incredibly meticulous final check is what guarantees that a $100 surgical screw will do its life-saving job flawlessly. So, from a simple piece of wire to a precision-engineered marvel, our little screw has been on quite a journey. But technology never, ever stands still, and the future of the thread is already being written as we speak. So, to quickly recap, it's this powerful trio: the way it's made, the way its surface is supercharged, and the obsessive way it's inspected, that elevates a screw from a simple fastener to a critical piece of engineering. Each step builds on the last to create something that is so much more than the sum of its parts. So what's next? Well, the next revolution is already here. Additive manufacturing. You know it as 3D printing. This tech promises to create screws with incredibly complex shapes that were just impossible to make before. Just imagine screws designed specifically for one patient's unique anatomy, or screws with internal lattice structures that encourage bone to grow right through them, creating a perfect, permanent bond. It's amazing stuff.
And all of this kind of leaves you with one big question, right? If this much science and engineering goes into a single screw, what other simple things do we overlook every single day? The world around us is just packed with these hidden engineering marvels waiting to be discovered. Thanks so much for joining us.